we have 1,000 adults. They were assigned to one of two groups. Half the volunteers were assigned to the experimental group that took a low-dose aspirin each day. The other half were assigned to the control group. At the end of 6 years, 15 of the people who took the low-dose aspirin had developed colon cancer, and 26 of the people who took the placebo had developed colon cancer at alpha 0.05. Is there evidence that taking low-dose aspirin would reduce the chance of developing colon cancer among all people similar to the volunteers? Okay, so here we go. We're going to begin with defining our variables. We'll say let. Now, we're dealing with proportions here because essentially we have 15 out of 500 and 26 out of 500. Hopefully you see that. I'm going to say let P of A be the proportion of volunteers who took, what were they taking? Low-dose aspirin and developed colon cancer. Let P of C be the, does it say control group? Just trying to save words here. Proportion of volunteers in the control group that developed colon cancer. Sometimes in these problems, they'll kind of define those variables for you, but if they don't, you need to yourself. Now, what we're trying to see is essentially, we have our HO here, and that is, well, is the proportion of people who took aspirin and developed colon cancer, is that less than the control group? Versus, or sorry, that's the alternative. So the null is assuming that they're equal. The null always has equality. And we're trying to see if P of A is less than P of C. Right now, again, the other way you can write this is HO. You can just subtract the P of C over. So now it'd be equal to 0. And the HA would be P of A minus P of C is less than 0. So that is what we are testing. Now, what is this? This is a two proportion comparison z-test. All right, so we are comparing two proportions. We're seeing how alike or different they are, and that is always a z-test if it's proportions. If it's means, you can pretty much guarantee it's always going to be a t-test. Okay, anyways, so let's check the conditions. So I'll say note, these samples were obtained randomly. You can read that they were assigned randomly. And 2, if 15 of 500 and 26 of 500 developed colon cancer in the respective groups. That's just a fancy way of saying this is for the first and this is for the second. I'll say then there are at least 10 successes and failures for each group. I'll say, so our test is valid. Now, sometimes they care about 3, sometimes they don't. 3 is we can assume that there are more than we can assume that we've sampled under 10% of the population of interest. Okay, but anyways, we've already spent 6 minutes just defining variables and making sure we're good to go, and that's because hopefully the rest of this goes by pretty quick. Now I'm going to go through everything by hand, sorry, as if I didn't have a calculator. So my z statistic, actually, so one thing I'm going to do is I'm going to say P of C before I dive in. P of C is, well, we'll just go in order actually. Actually, since P of C is already, I'm going to have to call this P of control, P of control, 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 control. Okay, sorry. So I'll say P hat of A was again the 15 out of 500. P hat of control was the 26 out of 500. And then we have this P hat of C, which you need to do when you're comparing two proportions, and that's the number of successes from each group divided by the sample size of each group. And so we get that P of C is, what is that, 41 out of 1,000. Sorry, couldn't see me write that down, but there we go. So with that being said, let's form our test statistic. Our test statistic is z equals, and the test statistic follows kind of what the null and alternative hypothesis look like. So we're going to have essentially the 15 out of 500. Now we could turn that into an actual percentage, probably should, minus the expected 0. Right? Again, we expect that they're not different. And we divide that by the standard deviation. And the standard deviation is given by, we have this formula here, P of C, 1 minus P of C, and then divided by the sample sizes each. So we have the 41 out of 1,000 times, the 1 minus that would be, gosh, that's 1,000. So 41 people out of 1,000 did get colon cancer, then 959 did not. Out of the 1,000 times 1 over 500 plus 1 over 500. Okay, let me calculate this. And we'll verify all this is correct using the calculator in a second. Plus 26. What I mean by that is we'll just actually do the z-test in the calculator. Now I don't have to write minus 0 here, but now I have to divide that by the square root of, again we get the 41 out of 1,000 times the 959 out of 1,000 times parentheses 1 over 500 plus 1 over 500. Goodness. And I feel pretty good about that. Okay, so our z-score is 6.53, actually I'll say 6.54. Maybe I'll put approximately because I'm rounding. All right, and I'll say the associated p-value is, and let's find out what the associated p-value is. If we have a z-score of, something went wrong here. Oh, sorry, I should be subtracting these two. See, I'm so glad I wrote it like this. Okay, these should be subtracted. My bad. I knew something was wrong because we're expecting, I mean, it should be smaller. The first should be smaller than the second, so again, when we do this, we should be getting a negative, and I wasn't getting that. That's why I freaked out and knew that something happened here. That's a minus instead. I also thought that this value was pretty large. Now I'm still doing the same thing. I'm dividing it by that same standard deviation. Okay, so this seems a little more reasonable. Something you would normally see. You can see really high values like that, but anyways, okay. Now we have that, the associated p-value for negative 1.75. Let's go to the negative 1.7 and 5. There it is, 0.0401. Okay, and we were supposed to test this at alpha equals 0.05. So I guess I'm just going to say, no, I'm going to write it down. Why not? If you have to do it, I'll do it. Say so. Since 0.0401 is less than alpha, which equals 0.05, I'll just say 0.05, or p-value is less than alpha, I'll just say it like that. We have, and now it's time to copy the last sentence, we have convincing statistical evidence that taking low-dose aspirin each day, I'll say will, since it does, will reduce the chance of developing colon cancer among all people, similar to the volunteers. Goodness. Okay, it's a lot of writing, but literally I just wrote down the last sentence. And so let's see how we did. I feel pretty confident about this. Let's look at the scoring guidelines. Question number 4, and I've got a minute and a half, so let's see. I might just have to speed up the video, but I did finish in less than 15 minutes. Again, your goal is to be done with any of these in under 15 minutes. Okay, so notice that they use aspirin and placebo. So again, you are totally allowed to define your variables however you want. Just make sure, notice what they did was they totally defined what they were in context. The one thing I didn't do is I didn't mention the within the 6 years. Now I maybe should do that, but hopefully that doesn't get things too bad. But we're doing a 2-sample z-test for comparing proportions. So again, I didn't use the exact wording, but 2 proportion comparison z-test, same idea. And let's see here, they were randomly assigned to one treatment. The condition is assignment. So we meet that. And then the sample sizes are large. Again, that is 15 and 26. And again, so essentially they're just talking about the fact that we have 10 successes or failures. Now what you should do also, I didn't do this, but I would go back. I still have, well, I don't have time anymore just for now. But technically, again, what this ensures is that your sampling distributions are approximately normal, or rather that they can be approximated by the normal distribution. Okay, so again, you see they have their P of C, P of combined, and placebo, and all that stuff. Now, again, we got the same value. They actually got theirs as a decimal, which I would recommend. I don't know why, I just for some reason didn't feel like doing that this time. But there we go. Now again, if you do the p-value from the table, there it is. If you do it from the calculator, you get this different value, but again, you would still reject. And so again, because the p-value is less than alpha, we reject the null hypothesis. The data does provide convincing evidence. So maybe you should just say reject the null, just to be clear, but let's go through and see if I met it all. So did I identify correct parameters? In other words, did I use proportions? And are both hypotheses labeled in the correct way? So did I write my HO and HA correctly? And I did. I put them equal to each other and less than, and then I actually put them both ways. So there we go. But you have to define your P of A and P of control and everything else. Okay. I identified the test by name, so the 2 proportion comparison z-test. I noted the use of random assignment, and I said that essentially we had greater than 10 successes for each group. So there we go. Let's see here. Now notice here, you do have to say random assignment check, but you can't just say random check or SRS check. You need to say that it was randomly assigned, so the samples were obtained randomly. So again, that would work to me as well. I guess I should say assigned randomly, but obtained, assigned, I'm going to give myself that. Okay, normality check may be used, expected counts. No, okay. Up next, again, get the correct value and p-value, and then conclude correctly. And you have to conclude in context. So notice, again, all I did was I wrote the last sentence. It's clear in context what we're talking about. We're not talking about z-scores and p-values. We're not talking about HO and HA. We're talking about taking low-dose aspirin, reducing the chance of developing colon cancer. Because if you don't talk about your exact test, you're just talking about numbers. Ultimately, statistics is using numbers to talk about real life. So that's the whole point of this question. Okay. Again, you also have to link that based on the p-value being less than alpha. And so there we go. That's about it. I think there's one last thing I wanted to mention. Oh yeah, how to do this in the calculator. So this whole step of getting to z and the p-value, you were totally allowed to just define these and then say in calculator, z was obtained, and then just do it. So if you have a calculator, that's what I'd be doing. Because again, you can go to stat, tests, 2 proportion z-test, just in case you forgot what it was. Again, x1 was 15, it was out of 500. x2 was 26, it was out of 500. And we're testing that the first is less than the second. And look at that, we're done. They give you the z-value, they give you the p-value, and they even give you, look, this one right here, this is the P of C, so they even calculate that for you if you didn't know you needed to. So really time saving.